Before you play the rest of the video, take a minute to look at this problem and find the mistake. So pause the video, see if you can find the mistake, and then turn it back on. Okay, I've assumed you've already done that now. So we're going to go through the steps. X to the 3/4 equals 5. The first thing I did is take log of both sides, which is perfectly okay. Then using the power property, brought the 3/4 out front, so 3/4 log x equals log 5. If I multiply both sides of the equation by 4/3, which is the reciprocal of 3/4, so 4/3 on both sides, then I get log of x equals 4/3 times log of 5, so still okay. 4/3 times log of 5 on the calculator. Okay, so if we do that, 4/3 times log of 5, I should clear this off, we've got a bunch of stuff on here. So 4 divided by 3 times log of 5. Okay, nothing wrong there. That's perfectly good. And then if I do 10 to that power, why did I do 10 to the power? Because this is log base 10 of x equals this number, so 10 to this power equals x. So let's double check that that is correct. Hit the wrong button. So 10 to this power is 8.54988, so that is also correct. So actually there are no mistakes in here. Okay, no mistakes. So why did I ask you to find the mistakes? Just being tricky. But there's actually a reason for this. There aren't any mistakes, but there's a much simpler way to do this problem. So let's rewrite it over here and do this the simpler way. This is not an exponential equation. In an exponential equation, the exponent is the variable, not the base. This is called a power function. It is a variable raised to a power. All I want to do is find what x equals. So I would like this to be x to the first. So if I were to just take both sides of the equation and raise it to the same power so that I get an x to the first, if I multiply 3/4 times 4/3, I get 1. So if I just raise both of these to the same power, x equals 5 to the 4/3 should be the solution. So let's just double check that. 5 to the 4/3 power. Same number. One step to solve this equation. So what was wrong in here was not that anything was wrong. You can do the problem this way. It's just not the most efficient way to do the problem. So this is how I would recommend solving a power function. Use reciprocal powers. So let's look at one that has a little more in it. So here I have 4 times 2x plus 3 to the negative 5/2 equals 7. Just like with exponential functions, I want to start by taking the base with its exponent and isolating that. So there is a 4 that is not affected by this exponent. I want to divide that out first. So divide both sides by 4 and I end up with 2x plus 3 to the negative 5/2 power is equal to 7/4. Well, I want it to be 2x plus 3 to the first power. So I need to multiply by the reciprocal, or raise it to a reciprocal power. So if I raise this to a reciprocal power, this would be negative 2/5. Oh, that's poorly. Let me rewrite this so you can actually see what I'm writing here. So this becomes 2x plus 3 to the negative 5/2 power equals 7/4. So if I raise both sides to the same power, I need to use the reciprocal of negative 5/2. The reciprocal is negative 2/5, because if I multiply a negative by a negative, I get a positive. 5/2 times 2/5 is 1. So I'm going to use the reciprocal power here, and this then would just become 2x plus 3 equals whatever that crazy number is. So I'm going to find that on my calculator. So I have in parentheses 7 divided by 4, and then outside the parentheses raise that to the negative 2/5 power. 2 divided by 5, and that gives me 0.79943, etc., etc. So let me write that down. 0.799438, da, 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 da. Okay, then I just need to subtract 3 and divide by 2. So 2x is equal to 0.799438 minus 3. Okay, so if I do minus 3 on the calculator, okay, that's negative 2.20562. So 2x equals negative 2.20056, and then divide everything by 2. So x is equal to negative 1.10028. Okay, now, is that an okay solution? It's negative. Well, this is not a problem. I'm not taking the log of a negative number. I can multiply 2 times a negative number plus 3 and raise it to a power, and I'm perfectly fine with this. So let's just double check. I need to divide this by 2. And let's just put it back into the original equation. So I have 4 times, in parentheses, 2 times the answer. Let's see, and I could just copy that, plus 3, and then I need to raise that to the negative 5/2 power, negative 5 divided by 2, and I got 7. Okay, so you can double check by just putting the number back in the equation. Okay, the next example, very similar. Once again, I want to isolate the base with its exponent. I have this plus 5 that's outside of the power function part. So the first thing I'm going to do is subtract 5, and I would end up with x minus 3 to the 4.16 equals 10. Once again, I want to use reciprocal powers. What's the reciprocal of 4.16? Well, the reciprocal of 4.16 is 1 over 4.16. So this is a case where I can't really use a root like a square root of radical to simplify this. This is a case where the reciprocal power is my only option. I could have used a radical on the previous problem. I'll go back and show you that. But in this case, this is really my only option. So I have x minus 3 equals 10 to the 1 over 4.16. Add 3 to both sides, and I would have 10 to the 1 over 4.16. I left the 1 out. 4.16 plus 3, and that would be my answer. If I evaluate that, I end up with 4.73934, etc. Okay, so if we go back and look at that, and you can check this if you want on your calculator, but I'm not going to go back and check that right now. This could also have been written, when I got to this step, I could have written this as the square root of 2x plus 3 to the negative 5 power. Okay, and in that case, I could have raised both sides to the negative 1/5 power and then squared both sides. Okay, so I could have done it slightly differently. I could have written it and done it a different way. For example, here, actually this is probably a better, I don't really like this example. This is probably a better example. I could have said that this is the cube root of x to the 4th equals 5. And then I could have said, oh, well, let's cube it. And I could have had then x to the 4th equals 125. And then I could have said, let's take the 4th root of both sides. And the 4th root of 125 ends up being the same number. Actually, I never did evaluate that. But the 4th root of 125 should be the same number, 8.549. Just for the heck of it, let's do that. If you're not sure how to do a 4th root, there is a button for it somewhere. Actually, right here, if you do Control and caret, then you can do 4th root like this of 125. But you could also do 125 to the 1/4. Somehow that didn't turn out right. So what did I do wrong? I know what I did wrong. I'm looking at it right now. This was actually the cube root of, let's see, I rewrote this. I wrote this wrong here. Okay. 5 to the 4/3. 5 to the 4th. Oh, I see what I did. The cube root, oh, I see what I did wrong. This should have been the 4th root of x cubed equals 5. So then I would have said, raise this to the 4th power, and I would have had x cubed is equal to 625, and then I would have done the cube root of x cubed equals the cube root of 625, so x equals the cube root of 625. And the cube root of 625 should be the correct answer. So let's double check that and see if I am correct now. The cube root of 625, yes, that is what I wanted. So, sorry about that, messed you up twice. You get to see that even your math teacher makes a lot of mistakes when she is not careful.